Hello everybody, I wanted to make a video here explaining each of the questions on the Unit 10 test. Should you have had any questions, I know it's difficult to ask those because, well, we're not there in person. So as you get your grade and you want to sort of reconcile that with the answers, this is, here we go, I guess. So it says determine how many options there are for each case. And again, yours could have been in a different order, but this is number one. So part A, a president and vice president are chosen from a 7-member service club. Okay, so for part A, we need to first determine if this is a combination or permutation, and it is a permutation. And the reason is because those president and vice president are distinct offices you could hold. So we're going to do 7, pick 2 on that one, and end up getting an answer of 42. Part B, 13 students apply for 3 scholarships of the same amount at the same university. So once again, permutation or combination. And this one, because these 3 scholarships aren't different from each other, but they're exactly the same, unlike part A, we're going to use a combination here. So we'll say 13, choose 3. And that gives us 286. Part C, how many word permutations can be made out of the word goddess ship? Well, first we want to count up how many letters there are, and you'll see that there are 11. So I'm going to go 11 factorial divided by, now I need to divide out any ones that are repeated and however many times they're repeating. So you'll notice that the D's repeat, and there's 2 of those, so I'll write a 2 factorial. And then you'll also notice that the S happens 3 times, so I'll write 3 factorial in the bottom there. And when you plug that into your calculator, you end up getting a pretty large number, but we get 3,326,400. And then on your test, you didn't put commas, but I'll go ahead and throw those commas on there. Number 2, there are 52 playing cards in a deck, and so on and so forth. So that gives all the information that we're sort of looking at. And so what we want to do is we want to find, oh, I guess I didn't put the question on here. Let me go ahead and do that real quick. All right, I'm back. So first one is we have, what is the probability of drawing a black card that is not a face card? Okay, so what we want to think about is we've got 52 cards, of course, and so we're going to end up with something out of 52. And if you were to figure out how many cards are black that are not a face card, you would end up with 20 total there. You simplify that, you get 5 out of 13. Part B, what is the probability of drawing a red jack followed by an even numbered card? It says do not replace the card after drawn. So in other words, we're going to draw the first card, and so we're going to assume that we did, and so the probability of pulling a red jack would be 2 out of 52. And we have the second event. Now keep in mind, that card is gone, so we have 51 cards. And now we need an even card. Well, we're going to have 20 cards which are even, because you've got 2 through 10, and we just do the evens there, so it gives you a total of 20 cards. You multiply those fractions, you simplify, you get 10 over 663. Okay, let's move on to the next problem. Given 4x minus 2y to the 6th, state what the coefficient would be for the following. Okay, so we want to find x to the 3rd, y to the 3rd, and then x squared, y to the 4th. Okay, so the first thing I'm going to do is I'm going to look at my Pascal's triangle. I'm going to remember, because it's hard to memorize all of these, but you've got on here a 1, a 6, a 15, 20, and then we just repeat. So those are our coefficients, or our multipliers, I should say, that are going to help us find our coefficients. We want to find the x to the 3rd, y to the 3rd. That's got to go right there in the middle. So we're going to end up with this 20 here. So we're looking at part A. So I'm going to have 20. Now I've got that 4x. I'm going to raise that to the 3rd power. and I've got the negative 2y. I'm going to raise that to the third power. So when you end up doing that, you get negative 10,240 x to the third, y to the third. So we're just going to put that coefficient. So we've got negative 10,240 is that first one. And let's go ahead and take a look at the next one. So we've got in part B, x squared y to the fourth. That's just going to be this term just to the right of that part A problem. So I'll have 15, 4x to the second, negative 2y to the fourth. And if you multiply all those out, 15 times 4 squared times negative 2 to the fourth, you end up getting 3,840. And then you would, of course, have x squared y to the fourth. We're just looking for the coefficient. So 3,840. Expand the following expression, 2x plus y to the third to the fourth. So let's go ahead and let's write our Pascal's row 4. So we've got 1, and then we're going to multiply that by 2x to the fourth, and then you'd have y to the third to the 0, so we'll just leave the y off. Then we're going to have 4, and then you'll have 2x to the third, and then y to the third to the first, plus 6, 2x to the second, y to the third to the second, plus 4, I'm running out of room here, 2x to the first, y to the third to the third, and then finally at the very end, I'll just sandwich that right down here, plus 1, and then the x is going to be to the 0, so I'll just leave that off. We'll have y to the third to the fourth. Okay, so now let's go ahead and let's simplify all this stuff. It's not too challenging of one, so we're going to get 16x to the fourth. Let me change that color up so we can see that. So 16x to the fourth plus 32x cubed y cubed, and then we'll have plus 24 x squared y to the sixth plus 8, look like a 6 there, plus 8x y to the ninth, and finally plus y to the 12th. Okay. Number 5. For the following sequence, provide the sum for the sequence. Round those answers to 1 decimal or to the nearest tenth if necessary. Okay, so the first thing I want to identify is when we go 1/9 divided by 1/3, we end up getting an R value, which is 1/3. So we're talking here geometric. I know that n is equal to 11 because of this 10. Remember, that exponent's always going to be n minus 1. So if you add 1 to 10, you get 11, of course. So we're going to have 11 terms. So this one's going to go pretty quickly. So we're going to have our sum. We're going to use that formula. And we'll have our a sub 1, parentheses 1 minus that r value raised to the number of terms, which is 11, and divide that by that 1 minus the r value. When you do that, you get approximately 0.5. I believe it's 0.49 with maybe 5 or 6 nines. We're gonna round that to 0.5. Okay. For the following sequence, provide the sum for the sequence. So in this particular one, you can see it's an arithmetic sequence. We've got a d value, which is the common difference of 10. Now we need to figure out n. We don't know what that is. So let's go ahead and let's plug that in. So we'll go the a sub n, which is 111. And that's going to equal negative 9, which is a sub 1, plus n minus 1 times that common difference 10. Now let's go ahead and solve for n, and I end up getting n equals 13. So then that's going to help me because now my sum formula will be 13 a sub 1 plus a sub n. And I'm going to divide that by 2. And when you do that, you get 663 is your sum for that sequence. Number 7, write the following sequence in summation notation. Okay, so we need to figure out what A, B, and C are equal to. So let's go ahead and let's get started by finding how many terms are in this. That's going to be A. So I'm going to write negative 37 equals, now I'm noticing that I'm subtracting here 4. So I know I have arithmetic, so I'm going to go 19 plus n minus 1 times negative 4. When you solve that, you get n equals 15. So right away, there is my A value, 15. Then all I need to do to find B and C is just simplify this right side here. When you do simplify it, you get an A sub n, which is equal to negative 4n plus 23. So if I look at this here, I'll notice that my B value will be negative 4, and my C value will be 23. Moving on to number 8, write the following sequence in summation notation. Now in this one here, you're going to notice we have a geometric situation. So it's going to change a little bit of the way I look at this, but let's first go ahead and let's find, I think the R value makes sense. So if you do 1.5 divided by 1, you're going to get an R value, which is 3/2, or you can say 1.5, it doesn't matter which. If you look at this here, you'll notice that's the C. So I'm going to go ahead and look at A, B, and C. I just found the C value. So maybe you write 3/2, maybe you write 1.5, either way. Now the B value, B is equal to A sub 1. So I'm kind of working backwards here, but that's a 1. Then you'll notice that this goes on to infinity. So our A value is going to be how many terms there are. Well, there's an infinite. So, and you can write infinite, infinity, up to you on that. All right. So now we need to decide if this converges or diverges. Now, as you take a look at this, you'll notice that it goes back and forth. 1, negative 1, 1, negative 1. That means we're multiplying by negative 1. And if you recall, we have to have a value that is less than 1 or greater than negative 1 if we're going to have a conversion. So if it's 1 or greater, it diverges, and that's what we have. So diverges because it's just going back and forth. If it's 1 or greater or negative 1 or less, it's going to be that divergent situation. And then, of course, we wouldn't have a sum because it's going on forever like that. But this next one, we are going to have something that converges because when you find the R value, if you go 1/4 divided by 3/8, you end up finding that your R value is equal to 2/3. 2/3 is below 1. So we're going to say that this converges. Now it's going to be up to us to find the sum. So we're going to take that R value. So we're going to write 3/8, which is our A sub 1. We're going to then take that R value and subtract it from 1. When you do that, you get 1.125. You can leave it like that if you want. You can write it as a fraction if you want, either way, but we got converging, and here is our sum. I believe that would be probably 9/8 or something like that, that last one, so for the fraction. Find the standard deviation, mean, median, and mode for the following information. Okay, so this is where you want to plug this into your calculator. Notice it says round to the nearest tenth. And so I'm just going to go into that L1. I'm just going to put in the data, 95, 31. It doesn't matter what order it's in. And just, kind of keep going, keep going. And then I'm going to hit that stat button and I'm going to calculate that one variable statistics. And when you do that, we're going to be looking at the following. So I've got S of X, which is our standard deviation for this sample space. We don't want to look at something bigger than that, so we just narrow it down to the sample space that we have. And you end up getting 33.6. I believe I rounded that. I could be wrong, but I believe I did. And then, because usually it's a decimal that kind of keeps going and going. So then I get a mean of 46.4. If I recall correctly, I think I also rounded that. Median, we get 44. That shouldn't be rounded. And then we have a mode, which is equal to 94, because that occurs twice. If you ever have any questions about, again, inputting stuff in your calculator, go back to that video that I posted. You can even, YouTube a video on stuff like that. Okay, now we're on the last problem. Mathematical induction. This is 9.6 question. So what would the piece of n plus 1 be equal to? So here we have a statement. We're going to assume that statement's true. We're going to assume the piece of 1 is true. So now let's go ahead and find out what that p sub n plus 1 would be equal to. And we'll also be able to use mathematical induction to find out, is this in fact a true statement? As you move towards infinity, is n plus 1 going to be true? N plus 2, n plus 3? If n plus 1 is true, it's true. So np sub 1, of course. So what I'm going to do is I'm going to have the 1 plus 2 plus 3 plus, and then we've just got n. So that simplifies things. And then all I have to do is just put plus n plus 1. So I'm just substituting n plus 1 in for n there on the end. And then I'm going to rewrite this right side. So I'll have n plus 1 times n plus 1 plus 1 divided by 2. Now all I need to do is just simplify, but what is helpful is just to say, okay, I know that this part right here is equal to n times n plus 1 over 2. I was told that in this statement. We're assuming that's true. So then I'll have plus n plus 1 equals n plus 1 times n plus 2 divided by 2. And I'm asking myself if this is true or not. So let's put a question mark there. Not that that's 100% necessary, but okay, let's go ahead and get a common denom here. So I've got n plus 1 plus 2 n plus 1 over 2. And I guess I'll go ahead and FOIL this right side here, might as well. So we'll have n squared plus 3n plus 2 over 2. So the right side's done. So let's see what this left side does. Does it actually simplify down to that? So we're going to have n squared plus n plus 2n plus 2 over 2. Let's bring this down. And if you take a look and notice, it does simplify to the exact same thing. We've got n squared plus 3n plus 2 over 2 equals n squared plus 3n plus 2 over 2. This is the answer we're looking for because that is the p sub n plus 1. And so you'll put in n squared plus 3n plus 2 divided by the 2. I hope this helps a lot. Great job on finishing this test in this unit. I know it's been challenging from a distance, but great work, everybody in Mr. Rutherford and Mrs. Hilvert's classes. Talk to you later.